Alright, this time we're going to use the hypergeometric distribution to answer this question about the salmonella poisoning. Alright, again we're looking for probabilities. Probabilities are under the Calc tab, and let's see, hypergeometric is right here. Now, when this window opens up, again I get the same options as the other distributions we've looked at, but this time the program wants to know some maybe different information. So first of all, we need to know how many units, people, whatever, in the population have the characteristic of interest. And we're told that there was a cookout and 12 people got salmonella. So the whole population are the 12 people who got the salmonella poisoning. And of those 12, we need to know how many who got the salmonella poisoning had eaten the homemade ice cream, and that turned out to be 11 of them. And the CDC, Center for Disease Control, decides that they're going to sample 4 of these 12 people. So they've sampled 4 out of the population of 12. And in the first question, we are being asked to find the probability that all 4 people ate the ice cream. So all 4 out of our 4 that were chosen. Okay, knowing that 11 of the 12 actually ate the ice cream, what's the probability that the 4 we picked also ate the ice cream? So in this case, we're simply going to want to know what's the probability that x is equal to 4. So I input my constant of 4, and there's my answer. So roughly a 67% chance that all 4 of the ones we picked had eaten the homemade ice cream. And in the second part of this question, we're being asked to find a probability that at least 2 people ate the homemade ice cream. So at least 2 includes 2 or more. And as we've seen before, the program will not do greater than or equal to. It'll only do less than or equal to. So if I want, what do I want? At least 2. So 2 or more, which means I need to find the probability of 1 or less. So find the probability that x is less than or equal to 1. And the answer is 0. Well, it's not 0, but it's probably 0.0000000, whatever. The number is so small that the program rounds it to 0. So if I take my total probability over all values of x, which is 1, and I subtract 0 from it, my answer is essentially going to be 1, or for all intents and purposes, it's going to be 100%.